All right, let's take a look at this argument. If the cat's away, then the mice will play. The cat's away. Therefore, the mice will play. Let's first write this argument symbolically. Symbolically, we have if P then Q, P, therefore Q. Let's look at this argument in a truth table. We'll have our starting columns, TT, FF, TF, TF by convention. Then we'll have a couple of columns for our premises. Premise 1 being if P then Q. Premise 2 is P. And a column for our conclusion. Which is Q. All right. We can transcribe P into this column for P, the second premise, and we can transcribe Q to the column for our conclusion. And then we have to investigate the premise with using the conditional. Now recall that the key point using the conditional is the only thing that makes the conditional false is if we have a true hypothesis leading us to a false conclusion. This is false. So when we're looking at if P then Q, we're looking at the P column to the Q column. The only line this key point happens is in line 2. Otherwise, T to T, F to T, F to F. Now, what we want to do is look at whenever both premises are true. So here we have both premises are true, then the conclusion is also true. This is the only time both premises are true, and we in fact have a valid argument. This argument is a commonly known valid argument, and it's called the Law of Detachment. If a movie is exciting, then it will gross a lot of money. This movie grossed a lot of money, therefore it is exciting. Let's write this in argument in symbolic form, where we have if P then Q, if P then Q, P, oh no, Q, sorry about that, therefore P. Exciting was P, money was Q. If P then Q, Q, therefore P. Let's take a look at this using a truth table. So we have our P column and our Q column, TT, FF by convention, TF, TF. Now we'll have our premise columns, or premises, where premise 1 was if P then Q, and premise 2 is Q. and a conclusion column where our conclusion is P. We can transcribe P into place and Q as the second premise. Now let's take a look at where we have the conditional if P, then Q. Recall again, the only thing that makes the conditional false is if we have a true hypothesis leading to a false conclusion. Which happens in the second row. T to T is T, T to F is F, F to T is T, F to F is T. Now we'll look at moments where both premises are true. The conclusion is also true. Well, let's look for other moments here in row 3. Both premises are true, but the conclusion is false. This is an invalid argument because a valid argument is such that when both premises are true, the conclusion is also true. That's only half of the time, so it's an invalid argument. This is a commonly known invalid argument, which we call the fallacy of the converse. So we have here the fallacy of the converse. Here we have the argument, I have fish or a lizard. I don't have fish, therefore I have a lizard. Let's first write this in symbolic form, where I have fish would be P. We have the or. I have a lizard would be Q. Our second premise is I don't have fish, so not P. Therefore, I have a lizard, Q. Symbolically, this is what our argument looks like. Let's take a look at the argument in the form of a truth table. So we have our startup column, T, T, F, F, T, F, T, F. Have columns for our premises. Premise 1 is P or Q. Premise 2 is not P. And we'll have a column for our conclusion, which is Q. P or Q. Remember the key point for an or is that the or is false only if all components are false. So we look at the P or Q and we look for double false, which happens here in the fourth row, otherwise true. We can transcribe not P over by reversing the truth values of P. So FF, TT, And we'll bring Q over to the conclusion location, TF. Now, what we're looking for is anytime both premises are true, that the conclusion is also true. That is a valid argument. This is a known valid argument. This is one of the known valid arguments. The name of this argument is the disjunctive syllogism. Disjunctive because we have that or. Disjunctive syllogism, a known valid argument. If more is spent on research, then medical science will advance. More is not spent on research, therefore medical science will not advance. Let's take a look at this argument symbolically. Here we have if P, then Q, not P, therefore not Q. Let's take a look at this argument in the form of a truth table where P is T, T, F, F, and Q is T, F, T, F. In the first couple of rows, we'll have the premises. And in the last row, we'll have our conclusion. Our first premise is if P, then Q. Our second premise is not P. Our conclusion is not Q. We can transcribe the P over. So not P turns T's to F's and F's to T's. And negating Q gives us F, T, F, T. Now we have to consider the key point for the conditional, which said the only thing that made the conditional false was if we had a true hypothesis leading to a false conclusion. That would be false. So we look at the columns P to Q, and in that second row, we have the key point, failure, F, otherwise T. And when we're checking to see if our argument is valid, then we are looking at the moments where both premises are true, and we're deciding if the conclusion is also true. And in row 4, it does work out, but in row 3, it does not. And if it fails even one time to be true for the conclusion, when both premises are true, then we have an invalid argument. And this is a known invalid argument. Therefore, it's a fallacy. This is called the fallacy of the inverse.